Okay, we're going to solve systems of equations using substitution and or elimination. First thing you need to know is that when you're solving using substitution or elimination, your equations should be in this form. You should have your x and your y on the same side and your constant on the right. Same thing with this. You should try to make sure your variables are lined up, and a lot of times textbooks will give you R and S, W and Z, or W and V. They give all kinds of different variables. There are two ways to solve: elimination and substitution. My personal preference, I don't know why, I just think that elimination is easier. With elimination, all you do is choose a variable and you find the multiple that these two coefficients would have in common, or these two, depending on which one you choose. After you find that multiple they have in common, you multiply both of your equations by that number, by whatever number it takes to make these be that same multiple. Then I always advise to check to see if those two numbers are opposites. And what I mean by that, one of them positive, one of them negative. If they're not, then you should also multiply one of those by a negative number, not just both positive. And I'll show you what I mean by that. For substitution, I only recommend substitution when you have a variable that's alone. And what I mean by that is if you have a coefficient of 1. When you have a variable, you have a variable with a coefficient of 1. Honestly, for myself, I find that it's easier for me to make a mistake using substitution than it is with the elimination. And I'm sure there are many people who feel the reverse is true. So I think you have to pick what you're most comfortable with. However, our next lesson we're going to be solving systems of 3 equations, and you have to know how to solve with elimination. So I want to show you those 3 problems. I found 3 problems in a book. If I make them up, we'll have fractions, and we don't want that right now. Okay, I think I'm going to start on the right. I cannot use, or I could, I don't want to. I could not use substitution for this personally. Why?
Because there isn't a common multiple.
There isn't a variable that's alone, that has 1 as its coefficient. Now, I agree that these do not have a common multiple, nor do these.
Okay.
I agree with that.
Okay.
However, what I can do, let me show you something really quickly before I do elimination. The reason why I would not choose substitution for this, I would not pick, let's say I'm going to pick x. If I subtract 2y from both sides, I'd have 5x equals 7 minus 2y. Divide by 5. I have a bunch of fractions. I know very few students who like to work with fractions. I think if we could choose between fractions or integers, whole numbers, I think all of us would choose whole numbers or integers. Not that we can't do fractions, but whole numbers and integers make us think a little less. I think that anyway. Okay, so like I said, I would do elimination for this one. So I'm gonna pick a variable. And you can pick X or Y, it's totally up to you. I think I'll pick Y, just because. Okay, so I'm gonna eliminate my Y. What multiple, 2, 4, 6, 8, 10, 12, 14, 16, 18, 7, 14, 21, 28, 35, 42, what multiple, what number did I just say that both of these have in common? 14. They both have 14 in common. So I want to multiply both equations by a number that will turn this into 14 and by a different number that will turn this into 14. What will I multiply this equation by to turn this into a 14? 7. And what will I multiply this equation by to turn this into 14? 2. Then, are these two coefficients currently opposite of one another? Is one a positive and one a negative?
No.
No. Then what I would do is pick one of these two numbers over here, 7 or 2, does not matter which one, and make it a negative number. Which one do you want to make negative?
7.
2.
7.
2.
7.
2.
7.
7.
Why would you do the top? If you want a subtraction problem, the top one's not
7.
mine. If you want to go.
She was close.
Minus
The
7.
pen was almost there.
It doesn't matter to me.
7.
Bottom.
7.
2.
Bottom one.
Majority
The
says
bottom
2.
one.
7.
But you don't listen to Jen. But
It's 3v2,
5.
4v2, 2.
I'm gonna go with Jed.
Yes.
Yeah, 2. 5.
Y'all can do the bottom and you'll get the same answer.
Do by
So
2.
do the bottom one, it's all right. All right, 35x. Oh, I'm gonna switch back to blue. Sorry, I couldn't take the pressure. So I went with the minority.
You're welcome.
Yes, sir.
Negative 35x minus 14y equals negative 49. Then 6x plus 14y equals 20. Now, I'm going to add these two together.
Yeah.
Never add them together until you have two coefficients that are the same but opposites of one another.
What would happen if they both canceled out?
That does happen sometimes, and it depends on if you've created a true statement or a false statement. If you have 0 equals 0, that's true, then there's infinitely many solutions. If you have 0 equals 10, that's false, that would be no solution. So if both of them cancel out, then it's either infinitely many solutions or no solution, depending on what your statement is that's left. Okay, negative 35x plus 6x is negative 29x. What happens to these two? What's negative 14 plus 14?
0. Cancel
0. They
out.
cancel out. They're eliminated. That's why it's called elimination. Equals, what's negative 49 plus 20?
Negative 29.
Negative 29. Divide both sides by negative 29. X is going to equal
1.
positive 1. Now, I want you to get into the habit of making an ordered pair, because when you're solving a system of equations, you're trying to find the point, I'll say it one more time, the point of intersection. So if you're talking about a point of intersection, you have an x coordinate and you also have a y coordinate. So just because you find one doesn't mean you're finished. You have to find the y coordinate. Now, how in the world do I go about finding the y coordinate only knowing x equals 1?
Plug it in.
Substitute it in. Where do I substitute it into?
For
The
the X.
x and with the top or the bottom?
Doesn't matter.
Or top or bottom?
Doesn't matter.
Doesn't matter. Which one do you want me to choose?
Five.
Bottom.
The
Three.
top?
Two.
I heard the top.
Bottom. Bottom.
Bottom.
Bottom.
Already chose.
Dang it.
5 times 1 is 5. Subtract 5 from both sides. Had to move it down, my video couldn't see.
Y equals.
So 2y equals 2. Divide both sides by 2. This happens sometimes. So y equals 1.
One.
So my solution, or the point of intersection, is 1, 1. Okay, let's do the middle one next.
Okay.
Actually, I take that back. Let's do this one next.
Don't you substitute though in, like,
For this one?
like in elimination, you're technically substituting still, right?
Well, you have to substitute to find, both substitution and elimination, you end up doing substitution. But for substitution, you substitute twice, actually. For elimination, you eliminate and then you substitute. But it's a different type of substitution when you're doing this down here. That's a different
Because you
type.
have to substitute the whole expression.
Exactly.
The-
You're substituting a value instead of an expression. Good. Okay, so I want to try this one. I can't go over 15 minutes or it won't post to YouTube. I want to try this one. I want to do substitution. So what you should do when you're doing substitution is you should pick a variable, x or y, that does not have a coefficient. And exactly, this y does not have a coefficient. So I'm going to choose y. I'm going to get it alone. How do I get this y alone?
Divide by x,
Divide
or subtract x.
by-
Yes, subtract x from both sides.
X from both.
So y equals, I like to put my x in the front. If you want to put 4 minus x, you can. But I'm going to put negative x plus 4. It's just a habit. Then to substitute, I'm going to put this expression in for y. That's what substitution is. Take that expression, substitute it in for y, and work out the problem. So 2x remains the same, the plus sign remains the same, 3 is going to be there, and the 9 is going to be there. But in place of the y, I'm going to put the expression that I isolated from the top equation. Never ever substitute this back into the one that we just isolated, because you're going to always get infinitely many solutions if you do that. So don't do that. Always substitute it into the other one. Okay, now I have no doubt that every single one of you in this room right now can solve this equation. You're going to distribute. So negative 3x plus 12 equals 9. You're going to combine like terms. Negative x plus 12 equals 9. You're going to subtract 12 on both sides. Negative x would equal negative 3. You're going to divide by negative 1. So x is going to equal positive 3. Okay, so I'm going to go back up here. Remember, my point of intersection, I got to have 2 answers. I know that x is 3. Now for y, just like when we were doing elimination, you can substitute in many different places. But I think there's one place that's obvious. Where should I put this positive 3?
And for x, the x by its.
That's where I would put it. You can put it anywhere you want.
Yeah.
And it'll work anywhere you have an x. But I think this one's the simplest. So I would have y equals negative, and then substitute 3 in for x, plus 4. What's negative 3 plus 4?
1.
1. So my point of intersection is 3, 1. Now I'm almost at my time. I better stop.